Nice having you again, my wonderful scholars. Jump past question 2001. Question number 34. The ratio of electrostatic force Fe to gravitational force Fg between two protons, each of charge E and mass m at a distance d x. The question is centered on comparison between electrostatic force and gravitational force. These are forces of nature, electrostatic force and gravitational force. The question is demanding for a ratio between the two. And mathematically, ratio means division. Okay, let's solve. Solution. Okay, let's call electrostatic force Fe and call gravitational force Fg, capital G's, subscript G. Follow the question. Be very careful with the question. The question says ratio of electrostatic force to gravitational force. So what comes first is electrostatic. What comes last is gravitational. Very, very important. Then Fe is to Fg. Fe is to Fg. That's what the question demands. Recall, electrostatic force stated by its columns entails Fe is equal to K Q1 Q2 all over R squared. This formula is called electrostatic force. Let me get it in other forms. This K is a constant, which means Fe is equal to, the K itself is 1 over, I won't write a 1, but it's there, 4 pi epsilon naught. Okay, let me put it. The K is 1 over 4 pi epsilon naught. Then Q1, Q2, all over R squared. Anything times 1 is that thing. Then we'll put away our 1, even though it's there. So these are electrostatic force by its columns. Then going back to the question, let's use the actual symbol the question demanded. The question is saying that we should use the distance. The R here implies distance. Then the R here implies distance. The question says I should use D. The Q here implies charge. Proton. Proton is a charge. Two charges, two protons. But the question is saying that I should use E for both. E1, E2. And they are the same. Since they are proton, proton, I can just say EE. Then let me now change this equation to suit what the question is asking. Also notice the options. We are going for this constant and not just K. 1 over 4 pi epsilon naught. That's similar to what we have in the option. So I'll take it this way now. Fe is equal to, instead of Q1, Q2, I'll be using E squared. Proton times proton is proton squared. Since they are the same charges, I can put it that way. 4 pi epsilon naught. Instead of R, I'll go for D squared. This distance, same idea as R, this charge. Okay, so these are electrostatic force. Then let's go to gravitational. Fg is equal to capital G, universal gravitational constant, m1, m2 over R squared. This gravitational force stated by Sir Isaac Newton. Okay? Then let's manipulate. We'll also take this R as D. Fg is equal to G, since the masses are the same, mass of a proton. So it will be the same. I can say m squared over, instead of R, I'll put what? I'll replace that with D squared. So these are the two forces of comparison. Then recall the question is saying ratio. Okay, let's go. Let's start with force of electron, electrostatic force. We have E squared over 4 pi epsilon naught, permittivity of free space, D squared, divided by, that's what ratio stands for. Then coming to gravitational, capital G, m squared over D squared. This is our question. Then let's do the arithmetics. Okay, I can now wipe it. Going on with the arithmetics. E squared over 4 pi epsilon naught D squared times D squared comes up, GM squared goes down. D square GM square. Okay, D square will cancel D square. So I'll be having E square times 1 is E square over 4 pi epsilon naught GM square. Okay, going to option. Notice the option there. You can see that the best option that describes this ratio is option D. Option D. Please stay tuned as we push ahead. Do subscribe.